We move ahead to the next module of stationary waves. In this module, what we are going to learn? We are going to learn the concept, or rather a very important phenomenon that is called as resonance. Now, what do I understand by resonance and how do I start about this topic? Students, remember, whenever you need to start about this topic, you need to understand the concept of forced vibration. Now students, we have already studied about the forced vibration. Forced vibration was the vibration of any body under the action of external periodic force, in which the body vibrates with a frequency equal to the frequency of external periodic force, that is the driving frequency, other than its natural frequency. And this frequency was the forced frequency, and these vibrations were called as the forced vibration. Now in this very module, students, we are going to study one special case of forced vibration, which is actually called as resonance. To start studying about the resonance, we need to first discuss about the amplitude of the forced vibration. Now it might so happen that I'm forcing some vibration into a body. The body might vibrate with less amplitude, or the body might vibrate with a more amplitude. So there is variation in amplitude. So can I say amplitude of forced vibration must depend on some quantity? And those quantities on which this amplitude depends are: number one, amplitude of the forced vibration depends on the amplitude of the applied force. Second thing, amplitude of the forced vibration depends on the difference in the frequency between the external periodic force and the natural frequency of the body. Third, the amplitude also depends on the damping nature of the body. So these are the three basic factors on which the amplitude of the forced vibration depends on. Mathematically, if I have to state, can I say amplitude depends on the difference of frequency? But how is it related? Students, it is related inversely. Amplitude is inversely proportional to difference in the frequencies between the natural frequency and the frequency of the external periodic force. In this formula, F is the frequency of the external periodic force, where N0 is the natural frequency of the body. From the following relation, we can state that if the difference in the frequency is more, then the amplitude must be less. And if the difference in the frequency is less, then the amplitude must be more. So I can state these 2 points, that if the difference in the frequency is large, then the amplitude must be small. And if the difference in the frequency is small, then the amplitude must be large. Now students, if I ask you a very important question, that when will the amplitude be maximum? So your answer will be when frequency of the forced vibration and the natural frequency both become same. When they are same, that means, can I say the difference will be the smallest? That means the difference will be 0. So amplitude will tend towards infinity, but for practical purpose it is not actually infinity, but amplitude is very, very large. So the maximum amplitude is obtained when the frequency is equal to the natural frequency. Moving ahead, to understand this concept, we take the help of a graph. In this case, I have amplitude on the y-axis and forced frequency on the x-axis. I also have the natural frequency of the body, and I plot the graph. When I plot the graph on the left-hand side, you can see the amplitude is less. On the moving towards the right-hand side, I can see the amplitude increasing, and moving more towards the right-hand side, the amplitude goes on decreasing. Now, why does this happen? On the left hand side, you can see the forced frequency and the natural frequency are having more difference. Hence, the amplitude is small. When it comes towards the right hand side, the difference goes on decreasing. Hence, the amplitude goes on increasing. And when I go more towards the right hand side, the difference goes on increasing, and hence the amplitude goes on decreasing. So again, the same statements, that we obtain a phenomenon of resonance at a point where the forced frequency becomes equal to the natural frequency. And the general statements we can state are once again that if the difference is large, the amplitude will be small, and if the difference is small, so the amplitude will be large. So on the basis of this, what conclusions can we make about the concept of resonance? Concept of resonance is a special case of forced vibration. In this case, the difference in the frequency between the external periodic force and the natural frequency is actually zero. And how do I define resonance? It is a phenomenon in which the body vibrates under the action of external periodic force whose frequency is equal to the natural frequency of the driven body, so that the amplitude becomes maximum. Students, we know that the amplitude was maximum only when the frequency of external periodic force was equal to the natural frequency, and this case is called as resonance. So students, with the help of this module, we actually understood the concept of resonance. We'll be seeing the further concepts in the next coming modules. Thank you.